Good day, scientists. Hope you all are good. On today's lesson, we will be doing a past paper question on work, energy, and power. So, now question says that a 12 kg block is initially at rest at this point here, point A. Then here we have point B. Then here we have point C. Ne? So it is here at point A, it's initially at rest. Ne? So it goes up the incline up until it reaches point B. Ne? So what happens is that now they are saying that this place is a rough inclined surface. Ne? So let's just write it here. Part A and B is a rough inclined surface. Ne? And then after the question says the block is pulled up by a constant force F. Ne? Constant force F, which pulls up, which is like force applied, but they didn't really give us the exact magnitude of the force. Acting upon the parallel incline, the block reaches B, which is vertical at height 4.5 angel. Then after it reaches B at the speed. So now here at A, it's at rest, the speed, and at B, it reaches there with a speed of 2.25 meters per second. And then now so then after that they ask us a question, and it says we must give or define the definition of non-consecutive force. So on non-consecutive force, we know that a force is non-consecutive if the work done on the moving object in a closed path is equals to 0. Ne? So now let's move to question 2. So on question 2, they're asking us about draw a free body diagram when it is going up the incline. So we need to draw a free body diagram when it's going up the incline. Now, what do we know about the free body diagram when it is going up the incline? We know that when it comes to the free body diagram up the incline, what is happening? First of all, it is going up the incline by this constant force that we don't know. Force F, which is like a force applied, then it is a rough surface, so we know definitely that it has a frictional force. Now it's on an incline, we will have normal force like this, and we also have Fg, like this. So, or you can either do it like this using the components. It all depends on the question, if they stated if whether you need to use the components or not. So here we know it's Fg parallel, and then here we know it's Fg perpendicular, and then we have the normal force. So we can either use this. Remember that normal force and Fg perpendicular are in the same magnitude but opposite direction if we are using the components. But if we don't use the components, we know that Fg is always acting downwards. So let's move further. So now on question 3, we need to calculate the work done by the non-consecutive forces when the block is moving from point A to point B. So now work done by non-consecutive forces, work done by non-consecutive forces. We know that the equation is EK plus delta EP. So now we know one thing about non-consecutive forces, that non-consecutive forces are like forces and get like frictional force and get the non-consecutive force. We have also applied force is also a non-consecutive force. So yet and yet we don't really know the magnitude of frictional force or the magnitude of non-consecutive force. So we cannot use this. Frictional force plus the work done by the applied force. We cannot use this because of we don't know. They didn't give us the magnitude of force F. They didn't even give us the magnitude of the frictional force. So we cannot use this. So we just have to use this particular thing. So we know that work done by the non-consecutive force is equals to delta EK plus delta EP. Okay? So at A and B, so we know it's half mv squared final and at B minus half mv squared at A initially, then added by the mgh at B minus mgh at A. Remember, it's only at this point and this point. We know that at this point the height is 0 and also the speed here was 0. So we know that the kinetic energy here is 0. Here we know that it arrives here with a speed of 2,25 meters per second. So we know that we will be able to calculate the kinetic energy. Yeah? So we know that work done by F is half 12 times 2,25 squared minus 0. Why 0? It's because of its initial address. So remember, when we multiply by 0, the answer will still give us 0 of everything. Okay? Then take this inside brackets. At B, the height is 4,5. So it's 12 times 9.8 times 4,5 minus and get minus 12 multiplied by 9.8 multiplied by 0. So you know that this will just give us 0 minus this, and this also will give us 0 here. So you know that here we are basically adding this, which is here 6. So let's now check in the calculator what is 12 multiplied by 9.8 multiplied by 4.5. So in our calculator, the answer here that we get is 30,375, and then minus 0, we just remove that 0, and then this will be 529,2. Add that together will give us 559,58 joules, which is the total of the non-consecutive work done by the non-consecutive force. Okay? So now let's go to question number 4. So now they are giving us information that the same constant force now moves in block F. So the same constant force that was the one that was used here, it's now the same force that is here now. So now they tell us that now as it is moving here now, it still has frictional force, but now they are telling us that the frictional force at point A at point B to C is 42 newtons greater or larger than the frictional force here. Remember, frictional force, it's changed now. So it's, if for example, if here maybe it was 5 newtons, here it will be 5 plus 42 newtons, which is will be equals to 47 newtons. So the frictional force, it's added by 42, but the constant force is the same. So now they're telling us that now as it moves here along B to C in this plane, it has a constant velocity. So now Now, since now the next question they're asking about the distance between here and here, remember which or what is the method that we can use. If we can find the work done by frictional force or work done by the force, we will know, okay, work done by the force is work done delta x cos theta. Remember, so we are just trying to separately find this particular thing here and this particular thing here, so that because we know that these two things added together, they're equals to the non-consecutive force, then it will be easy for us to find now the delta x, because it's the same in both of these two. So what are we basically doing? We are just finding, because of now here they told us that the force is the same. So because we know that the force is the same here and here, so if we can use F net here and find the force here, then it will be easy for us to find the frictional force, or then we will just be able to find the distance here. So now they told us that B to C is 42 more, and so we can just say at B to C it's F plus 42, or we can just say X plus 42 is the same. X just represents the unknown value of the frictional force, although this is constant. So now they told us that at B to C, F net on B to C, BC, and we know that it's the only forces acting here. There are just two forces. It's force applied, that F, minus the frictional force, and yet it's going that way. So we have F, we have frictional force, and yet so the only two forces acting here on horizontal by F net, it's frictional force and this force. So now here we can just do this is equals to MA, but they told us that we have constant velocity. So if we have constant velocity, we know that this F net will be equal to 0. But we know that here this acceleration is how much? Is 42 times more. So it's just basically this particular thing here. So it's F plus 42. Then now we know that both of this, or no, the difference of this will be 42 newtons, and just take 42 to the other side. We know that F minus F, the force applied minus F, will be 42. Or we can just say, basically do using equations, we can just do simultaneous and say give 42 here plus frictional force, which will be equal to the force here. So we know that the force here, it's 42 plus the frictional force, and which is, we can just do it as equation 1. So here it's just basically using what we have here to that side, because we know that this and this is a constant thing, so we can just basically use simultaneous. If you find F here, we will use the same on this side here. So now here we know that this force is the same force that is here. So now what do we know then? Using the previous thing from point A to B, we know that non-consecutive force, it's the force added to the frictional force, and so now let's try to do it. But everywhere we see the force, we just substitute by this particular thing. Everywhere we see F, we substitute by this. So because of we know that the work done by non-consecutive force, we found it was equals to 5 and comma 58. Then we know that non-consecutive force is the work done by the frictional force added by the work done by the force, and so let's basically use this formula, these two formulas, so that we'll be able to basically we are just taking these formulas because of we have to find this, Sanjay. So we take in the formulas that have this, so that when we will be solving for it, we will know how to deal with this thing. Eh? So now we know it's f delta x cos theta plus f delta x cos theta. All of them, that equals to 559,58. So now let's just deal with this side. Remember, here we did simultaneous, and we found that the force is equals to the frictional force plus 42. So basically now, everywhere, remember I said everywhere we see this, let's substitute with 42 plus f, so that we will have only just one thing. Ne? So we will just have one unknown. Then it will be easy for us to cancel it out. Ne? So we know that here it is 42 plus f, frictional force. Then now here it's delta x, we don't know, we're looking for it, cos 0, ne? Because of it's going up, and here it's going up. So now add it to frictional force delta x cos 180, because of its 18 downwards angle. So now from here, what do we do is that because of here we did simultaneous, so now it's easy for us to now say that now let's just simplify everything. So here we know it will be 42 plus frictional force, then delta x plus frictional force delta x. So here it will be negative, sorry for that, and here this cos 180 is negative, so let's just put negative here. So we know that it will be this minus this. So but we have 42, ne? So now we can do this, ne? So let's just factorize everything here, ne? So it will be 42 multiplied by delta x plus frictional force multiplied by delta x. We're just separating everything, and then minus frictional force delta x. So these two things, they have opposite signs, so they are additive inverses. So let's just cancel them out. So after that, here we will have 42x, and 42 delta x is equals to this 559,58 joules. So we divide everything by 42. Let's check the answer in the calculator. Then our final answer is just 13,32 newtons. So this is our final answer. So I hope you enjoyed the video. Don't forget to like, to share, to subscribe the video to as much as you can, and yeah, see you all in the next video. Sharp.